Okay, okay, okay. Okay, fine. So, hello everyone. Good evening to all. My name is Abhishek Pandey. I am a Prime Minister Research Fellow in the Discipline of Mathematics at IIT Bhubaneswar. Today we are going to discuss about week 2 assignment. So, let us start. So, this is the first question. Which of the following are true? So the first option is the function f such that c to c given by fz equals to e to the power z square is an entire function. So let hz is equals to z square and gz equals to e to the power z. As so fz will be composition of g and h. It is clear that g and h is entire and composition of entire function is entire. Therefore, f is also entire. Okay. Now so option 1 is correct. Okay, option 1 is true. Second, second option is if f is an entire function and g is not an entire function, then f plus g not an entire function. Okay. So suppose that f plus g is also an entire function. So f plus g is also an entire function where f is entire and g is not entire. Okay. So consider f plus g equals to h. So this implies g equals to h minus f. Now f is entire and by our supposition h is also entire. So g is equals to hf minus f is also entire, which is a contradiction. Thus f plus g is not entire. Okay. So option B is false. Okay. Now option third is about the existence of two functions. So it asks there exist two functions f comma g such that c to c both of which are not entire but f plus g is entire. Okay. So let f such that c to c f of z equals to x means real part of z and g such that c to c g of x equals to iy means I into imaginary part of z. Now f plus g, now here we can see this is not entire, not entire, and this g is also not entire. Thus f plus g such that c to c, so f plus g of z will be x plus iy. Okay, and this is nothing but identity mapping which is entire. So basically you can construct two functions which are not entire but their summation is entire. Okay, so option C is also true. Let us look at the option 4. If f is an entire function and let p be a polynomial in one variable, then composition pfz is an entire function. Okay. So as we know, composition of two entire function is entire and polynomial is always entire. Okay. So we get that composition of polynomial with an entire function f is also entire. Okay. So this option is also true. The last option is the exponential function is surjective. Okay. So let us suppose it is surjective. Okay. So therefore there exists z naught belongs to C such that f of z naught equals to 0 means e to the power z naught equals to 0. As we know that e to the power 0 equals to 1, so 0 we can write it as z naught minus z naught. Okay. So it will be e to the power z minus z naught equals to 1. This implies e to the power z naught into e to the power minus z naught equals to 1. This implies 0 equals to 1, which is a contradiction. Okay. So option 5 is not true. Okay, fine. Let us look at the second question. This is basically a very good question. It is upon the isometries of the complex. So let I denote the set of isometries of C which fix the origin. Okay. Observe that I forms the group under composition. Which of the following statements are true? Okay. So remember that I denote the set of isometry of C which fix the origin. Okay. Now, what do you mean by isometry? So isometry means distance between Fz and Fw is basically equals to distance between Z and W. Okay. For any Z comma W belongs to complex plane C. Okay. Now this is a general state. This is a general statement. Like any isometry is of the form this. Okay. Where mod A equals to 1. So let us try to prove this one. Okay. So before going to learn the option, we will first prove the above statement. Let F says that C to C is an isometry. Okay. Then construct Gz is equals to Fz minus F naught. So it will be G of 0 equals to 0. Now observe that G is also an isometry which fixes origin. Now define Hz equals to Gz upon G of 1. Now G of 1 is non-zero. Okay, G of 1 is non-zero because G is an isometry. It is 1 1. So G of 0 is already 0. G of 1 should be non-zero. Now observe that H is also an isometry which fixes 0 and 1. Now claim is Hz is either Z or Z bar. Since S is an isometry, this holds. Okay. Now, if we put W equals to 0, this will be mod of Sz equals to mod Z for all Z belongs to C. This is fine. And okay. So H also fixes 1. Okay. So here you put W equals to 1. So it will be Hz minus 1 equals to mod Z minus 1. Okay. So from 2 we have just a square both sides. So after the calculation, you will get this term. Okay, Hz plus Hz bar equals to Z plus Z bar. So this basically means real part of Hz equals to real part of Z. And since mod of Hz equals to mod Z, we get imaginary part of Hz is nothing but plus minus imaginary part of Z. Thus, Hz is either Z or Z bar. So from this, after the calculation, you will get every isometry F is nothing but Az plus B or Az bar plus B, where mod of A equals to 1. Okay? Fine. So now let us look at the options. So option D is let phi be in an isometry of C, then phi z is equals to alpha z plus z naught for all z belongs to C, or phi z equals to alpha z bar plus z naught for all z belongs to C. For some fixed z naught belongs to C and mod alpha equals to 1. So means the way we have proved here, this is what we have proved. Thus option D is true, and hence option E is false and option F is true. So option D is true, option E is false. So option E is asking let phi be an isometry of C, then phi does not have a fixed point. Okay. So such kind of form Az plus B upon Az plus B equals to Z if you put, so you will get some kind of fixed point. Okay. Now, our last option is let phi be the isometry given by phi z equals to Z plus Z naught for some fixed Z naught, then phi does not have a fixed point. Okay. So this you can see like Z equals Z plus Z naught equals to Z. So Z naught should be 0. Okay. But Z naught is non-zero. So this option is also false. Sorry, this option is also true. Okay. Now let us look at the first option. Suppose that z is not equals to w are two non-zero complex numbers. The only isometry in I, remember, I denote the set of all isometries which fix the origin. Okay. So the only isometry in I which fixes both z and w is the identity map. So you can take basically z bar and z comma w is a real number. Okay, like here I have given the example. Let z equals to 1 and w equals to 2. So fz equals to z bar is an isometry which fixes 1 and 2, also 0, but it is not identity. Okay. So option A is not true. Now option B. Suppose z comma w are two non-zero complex numbers. Then there always exists a non-trivial isometry which is not the identity in I, which fixes both z and w. Okay. So let us look at this option. Yeah. So for option B, uh, one thing we need to consider is let z naught is not equals to w naught are two non-zero complex numbers. Now consider the isometry of the form. This isometry we have to check in I. Okay. So in this case, since so it has to fix origin. Okay. So phi of 0 should be 0. So means B should be 0. B should be 0 already. Okay. So now, if you look at this one, wait. So B should be 0 because it is fixing origin. Phi belongs to I. Okay. So phi of z is nothing but az. Okay. And also phi of z naught is nothing but a of z naught. And this is equals to z naught because it is fixing z naught and w naught. And phi of w naught is nothing but a of w naught is equals to w naught. So basically a, we are getting a equals to 1. So phi z is basically z. Okay. So this type of isometry will always be identity when we are talking about fixing of 2 points. Okay, z naught and w naught. Now we also have isometry of this form. Okay, so here also b is equals to 0 since phi belongs to I. Okay. Now let us look. So phi of z naught is equals to a z naught bar is equals to z naught, and phi of w naught is equals to a w naught bar is equals to w naught. So this will give a is equals to z naught upon z naught bar. Okay, and this will gives a equals to w naught upon w naught bar. Okay. So the thing is, now for different, here z naught is not equals to w naught. Okay. So for different choices of z naught and w naught, we will get different a, isn't it? Hello. Hello. Is it clear? Hello. Can anyone respond? Okay. So for different Z naught and W naught, we will get different A's. Okay. But we need an isometry which fixes both Z naught and W naught. So if you choose A this will fix Z naught. And if you choose this, it will fix W naught. But simultaneously they have to fix. Okay. So for that, we need Z naught upon Z naught bar equals to W naught upon W naught bar. So we need Z naught upon Z naught bar, W naught upon W naught bar. This we need. Now it is easy for you to check that it will become trivial. Okay. So option, it is option B. So this is also false. Now let us look at the last option. So option C. So option C is about, let Z comma W be two non-zero complex numbers such that W is of the form R into Z. So basically geometrically you can see, suppose Z is here, okay? So Z is suppose R naught e to the power I theta naught, okay? So W equals to R into R naught e to the power I theta naught. So basically what this will do, RZ, this will either send W here, some points here, okay, on this radial line, or some point here, okay, depending upon the R, okay. If R is less than 1, so it will be less than R naught. So basically this is your R naught, okay, and this up to this distance or this distance is R into R naught, okay. Now what we need to do, let L be the line joining 0, W and Z. So let L be the line. So this is the line, okay, or if W is here, then this is the line. So let us call it L, okay. So reflection about line L will be the required isometry. Like as we know, for the x-axis, so reflection about f-axis is nothing but, so reflection I will denote R, RAF. So reflection about x-axis is nothing but Z bar, okay. So we need to find the, so and Z bar is isometry, okay. So what you need to do, just rotate, suppose is a theta naught, just rotate this line to x-axis, okay. So this will be on x-axis, rotation map you will apply, okay. And then what you do, you will apply the Z bar, okay, because rotation about x-axis is Z equals to Z bar. Sorry, f of Z equals to Z bar is the reflection about x-axis. So this reflection about the line L will be the required isometry, okay, and it will obviously fix 0, W and W naught. So reflection means whatever will be here, suppose Z is there, so it will come here under the reflection of Z naught. So say Z naught. So this is reflection of Z, okay. So you can find the, like this is a perpendicular difference using the elementary coordinate geometry. You can find the coordinate of this point. Suppose it is of x comma y, x naught comma y naught. So you can find the coordinate of this point, okay, and coordinate of this point will be your required mapping, okay. Is this clear? This question is clear to everyone? So option C is true. Yeah, any question? Any question? Is it okay?
Yes, sir.
Okay. So I will move toward the next question. So question number third. So question number third is, first I will define the capital ARG. Capital ARG. So it is basically the principal argument. Okay. So for non-zero complex number Z belongs to C. Argument of Z is the real number theta in between minus pi to close pi, such that Z equals to R e to the power I theta for some R positive. So we have to compute this argument. What is the value of this? Now let Z is equals to R e to I theta, where R is positive. So 1 by Z will be 1 by R e to the power minus iota theta. So argument of 1 by Z will be minus theta equals to minus argument of Z. So similarly, argument of this quantity will be minus argument of this. And argument of this nothing but minus 5 pi by 6. So it will be 5 pi by 6. Now 6 by pi into this is nothing but 5. This is just based on the calculation. Okay, so it is easy to compute. Now let us look at the fourth question. So compute 4 upon pi into argument of 1 plus I to the power whole 7. Now let us look at what is 1 plus I. So it is root 2 into e to the power I pi by 4. Okay. So now 1 plus I to the power 7 will be under root 2 7 e to the power I 7 pi by 4. So since this we need to take modulo 2 pi, okay, so that it will belongs to minus pi to pi, okay. So argument of this will be minus pi by 4. So you just need 2 pi minus 7, sorry. So it is 7 pi by 4 minus 2 pi is equals to minus pi by 4, okay. And 4 upon pi multiply, so it will get minus 1. So this is basically modulo 2 pi, so that it will come into the minus pi to pi range. Now the fifth question is, which of the following identities slash inequalities are true? So recall that these are the options, okay. So recall that the definition of cos z, cos hyperbolic z, sin z, and sin hyperbolic of sin z. So it is e to the power iz plus e to the power minus iz, and this definition. Okay. So after the direct computation, it follows that option 1, 3, 4, 5 are true. So this is true, this is true, this is true, this is true. Now we only need to check option second. So for option second, let z equals to it. Z is of this form. Okay. So 2I sin it is equals to e to the power minus t minus e to the power t. So basically sin it will give you this, and modulus of sin it will give you this. Okay. Now for sufficiently large t, this will be greater than 1. From here you can observe. So precisely you can take t equals to 10. So sin I10 is equals to e to the minus 10 minus e to the power 10 upon 2. So this will be obviously greater than 1. Okay. So this option is not true. This option is false. Now let us look at the sixth question. So it is based on the Cauchy-Riemann equation. Let omega be an open connected subset. So open connected subset is called as domain. Domain. Okay. And F says that sigma to C is, or omega to C is holomorphic. Okay. Now take f equals to u plus iv, where u equals to real part of f and imaginary part of v. Now, Cauchy-Riemann equation is this: ux equals to vy and uy equals to minus vx. Thus, option 1 is false. Option 1 is saying ux equals to minus vy and uy equals to minus vy. So this is false because CR equation is ux equals to vy and uy equals to minus vx. Okay, fine. Option is fine. So now let us check. Let us check if f is holomorphic. What can we say about holomorphicity of f bar? Okay, let us look at this one. So f, so let f equals to u x comma y plus iv of x comma y is holomorphic on omega. Now f bar is nothing but this. Suppose f bar is also holomorphic on omega. So it will satisfy Cauchy-Riemann equation of f. So then using Cauchy-Riemann equation of f, we will get this. And using Cauchy-Riemann equation on f bar, we get this. Now once you combine these two equations, you will get all the partial derivatives equals to 0. So this gives df upon dz is equals to ux plus ivx, which is 0. And since your given domain is connected, f is constant. Thus we get that f and f bar are both holomorphic if and only if f is constant. Thus option B is false. So this option is also false. Now let us look at the third option. The function f bar is holomorphic if and only if this happens. Okay, so this is basically the Cauchy-Riemann equation of f bar. Okay, so this is true. The function, if the function f bar is also holomorphic omega, then ux and uy are identically 0. This is also true, the way we have showed. If the function f bar is also holomorphic omega, then f is constant. This also we have shown. So this is also true. So this is the end of the assignment. Thank you, everyone. So anyone have any question? Please ask. Hello. Hello. Can anyone respond?
Hello, sir.
Yes.
Please repeat the problem on isometry again.
Okay, sure. So in particular, which option you are facing problem? This is the question, second question. Yeah. So have you understand this one? Any isometry is of the form this and this. Proof you have understand?
Yes, sir.
Okay. Okay, so let us see the first option again. So suppose z is not equals to w are two non-zero complex numbers. The only isometry in I which fixes both z and w is the identity. So here what you can do, take z equals to 1, w equals to 2, okay, and fz is equals to z bar. Now f is isometry, fixing origin means f belongs to I. And also f fixing 1 and 2, but f is not identity. So this option is false. Is it clear?
Yes.
Okay. Now if you look at the option B, suppose that z is not equals to w are two non-zero complex number, then there always exists non-trivial isometry in I which fixes both z and w. Okay. So this I have given in a general form, option B. So we are only having isometry of the form az plus b and az plus b bar. Sorry, az bar plus b. So these isometry have to fix origin. So first isometry will become az, second isometry will become az bar. Okay. Now this kind of isometry fixing 2 points is not possible. Okay. Only when it is identity. This we have shown here. Okay. And for this kind of isometry, we got this condition. Is it clear?
Yes, sir.
Okay. Now the third question is, suppose that z is not equals to w are two non-zero complex numbers such that w equals to rz, where r is non-zero real number. Then there exists a non-trivial isometry in I which fixes both z and w. Okay, so geometrically you can understand this one. So let z comma w be two non-zero complex numbers such that w equals to rz, where r belongs to r minus 0. Okay. So basically, geometrically you can see where w lies. Okay. So suppose your z is here, so w will lie here and here, depending upon r. Is it clear? This picture is clear? Hello?
Please explain this, sir.
Okay. So z is basically r naught e to the power I theta naught. Okay. Now if you do rz, it will be r naught e to the power I theta naught. So this r naught, see, argument is same. Argument of w and argument of z same, theta naught. Okay. Only this one is changing. So it will be less than r naught if r is less than 1, and it will be greater than equals to r naught if r is greater than 1. Okay. So w will lie here if this hold, if w will lie here if r is greater than 1. So depending upon r, w will lie, but it will be collinear to this one. Okay. So if you join from origin to z, on that line w will lie. Is it clear?
Yes.
Okay. So now let L be the line joining 0, W and Z. So reflection about the line L will be the required isometry. Basically, like reflection about x is nothing but Z bar. So you have any point here. So reflection will be, this distance will be equal to this one, and this will be reflection of Z. And once you compute, it will be Z bar. Okay. And this distance will be same. So basically, using coordinate geometry, you can find the coordinate of this one. So if x comma y, say, so this will be x comma minus y. Okay. So similarly, here also you can find if z naught is here. So reflection about this line means z naught will be here. Okay. So using the coordinate geometry, you can find the coordinate of this reflection of z naught. Okay. So what you need to do is you just rotate this line to x-axis. Okay. And then use this one, that reflection about x-axis is nothing but z equals f of z equals to z bar. Okay. So reflection about the line L will be the required isometry. It will fix 0, W and Z, because for these point reflection will be itself. Okay. and it also fixing origin. So this reflection will belongs to basically I. Okay. So option C is also true. Okay, fine. Any other question? Is it clear?
Yes.
Okay, fine. Any other question from anyone? Hello? Any other question? So if no question is then I will close the meeting. Any question?
No, sir.
Okay, thank you. Okay, we will meet again on next Friday at the same time, 7 to 8 p.m. Okay.
Sir, one request.
Yeah.
If you kindly supply the question before this class, then it will be very helpful.
Okay, so that we need to ask about, so this thing I need to ask to our committee whether we can do such kind of thing or not. And I will let you know in this next session. Is it okay?
Okay, sir.
Okay. Okay, so I will close the meeting. Okay, thank you everyone.